Right, for exit slip 5-4, we are dealing with decomposing complex polygons into simpler polygons that we can find the area of, and using that to be able to find the area of this whole figure. There are a lot of ways we can decompose or break this thing up into different shapes. I'm just going to model one example here. One thing I'm going to do, I see here if I add a little triangle right there, okay, that I've actually made a rectangle, big rectangle right here. So I'm going to go ahead and like visualize and cut it up this way. So again, I've made this rectangle shape out here, and I've got another rectangle here. All right, so the way I've chosen to do this, I can find the area of this rectangle. I can find the area of this rectangle that I created, but I added on some stuff that wasn't there. So I'll have to subtract that stuff out to figure the area of that part, and then I can combine it all. So this takes quite a bit of work with the area that we've been using. All right, so let's break it down into parts here. Let's do the big rectangle first. The big rectangle is 20 by 16. So we know area equals length times width. So if I take 20 times 16, again, I'm not going to do the work here. You guys can use calculators to do this. That's fine. 20 by 16, you're going to get 320 square centimeters in here if you multiply 20 by 16. So I know I've got 320 square centimeters in that big rectangle. Okay, now I'm also going to find the area by taking length times width of this rectangle. And I know this rectangle is 8. Okay, so from here to here I know is 8. Okay, because it's 8 down here. And I know from here to here is 8. And from here to here is 4, because it tells me that. So I know from here to here has to be 4, because these triangles are the same. So I'd have to add all that up to get my total. So 8 plus 4 is 12, plus 4 more is 16. So really I'm taking 16 by 8 to find the area. 16 times 8 would get me the area of this big one here. And 16 times 8 is 128 square centimeters. And I know there's 128 then in this thing completely. But I need to subtract out these little imaginary things that I added in here, these triangles. Okay, so I see each of these triangles are 8 by 4. And I know to find the formula of a triangle, you have to take base times height and cut it in half. So base times height, this would be 8 by 4. So I know 8 times 4 is 32. If I cut that in half, I get 16. So this little thing is 16 square centimeters. So that means this little triangle has the area of 16 square centimeters. So I need to take both of those out of this big rectangle that I made right here that was 128. So I know if this is 16 and 16, that's 32 when I add them together. So I need to take this 128 square centimeters in this whole rectangle and subtract out that 32. Okay, and if I do that, I get 96 square centimeters. That is in this area right here, this trapezoid, because I've taken out and subtracted those out. But I now need to take this 96 that's here, and I need to add it to the rectangle over here, and that will give me the area of this whole complex shape. So 320 plus 96, I get 416. So what's the area of the sandbox? 416, and remember it's square centimeters. Again, I'll write it with a little 2 symbol there. That means square. So there'd be 416 of those little squares that fit inside there of area to play in that sandbox. Again, there are other ways to do this. Again, we're not going to do it another way. I'll pause this to make sure you have all the work written down, but it does take a lot of area work, and you got to do a lot of little things right to get this whole problem correct. So you got to be very, very precise and attend to precision when you're doing this math work. Okay, and if I erase this real quick, another way some of you may see to break this up is I could have done this, decompose this polygon, and I could have done it this way. And if I did that, then I would have to find the area of that, which is the same, and then find the area of this rectangle in here, the area of that little triangle and that little triangle, and I could have added them all up. Okay, that was different than my thinking where I added on here and did this big rectangle and subtracted things out. I could still find the area of all three of these little pieces and add them up, and you're going to get the same answer. So again, be very precise. Got to do a lot of things right here in order to get a problem like this correct.